Hey guys, my name is Nogan and welcome to my C++ series. So, I hope you guys doing good. Now in today's video, awesome. So in today's video, we're gonna be focusing on dynamic memory allocation in C++. So we'll learn what is a new and delete operator in C++, and also we'll understand how we can use them and how are they also being linked to become form of raw pointers, and how are they different from smart pointers. But before we continue, if you guys didn't watch the previous video, we looked at the array operator in C++. Let me link card on top there, so go and check it out, because there we use similar structures of programming, and a bit before it also about using a new and delete keyword operator in C++. But now, as you can see here with a standard empty project here. Now, before we start to write some code, let's understand what is the new and delete keyword to in C++ eventually. Now, in C++, the new and delete operators are used for dynamic memory allocation and deallocation also, which means they allow you to allocate memory on the heap, so which means free storage at runtime and release it when it's no longer going to be needed, of course, in your program. So you'll see in a moment how we defined it. Okay, when it comes to the syntax of that, let's just define a few variables now. In the main function here, I'm going to declare an int. I will include the asterisk here to signify and be a pointer, and ptr the variable name. Using the equal sign, the assignment operator, the new keyword int again. Okay, so as you can see now here, eventually the new keyword allows you to allocate memory dynamically now on the heap, which means it's going to be memory going to be accessed now on runtime when the program is running. So after this, I'll say ptr again. We're going to try to eventually now initialize this memory by allocating it with a value. Let's say, for example, we're going to store in there. But before we store it in there, let's just first try to have a statement. This is an if statement, so we can just try to have a condition to see what's happening eventually. Let's say if ptr is not equal to the null pointer. Now in here, let's just initialize it, ptr again. Good sign. Let's say this just stored at 35. It's an integer. Let's go to CR statement also, so you can see the store value. So dynamic allocate value. So again here I'm going to say again ptr to dereference eventually the variable you see is going to be stored inside of it. Awesome. So after this, very important also you can note, when you are allocating now based using the new keyword in your program, you have to also use now the other operator, the one that needs to release the memory from initialization, which is going to be now the delete keyword. So after the if statement here, I'm going to come here and just say delete ptr like this. Awesome. Which means these two are very fundamental, because the new keyword needs to have a delete keyword also, which means, because think about it, when you have something is being opening, someone opening and closing a door, when you open a door, you have to close the door after when you enter, which means the new keyword needs to be defined as a means of now trying to declare the variable in the heap when based on runtime. The delete will try to release the memory now after runtime to avoid memory leakages in your program. So after this, control should be the compiler program. Okay, succeeded. Awesome. Let's just run this on top here. Awesome. As you can see now, we have a message saying now dynamic allocate values in 45. Okay. Let's try and analyze this thing more deeply. I'm gonna come here at line 7 here and just click there with the red dot, which means I want to just use breakpoints to see what's happening. I'm gonna run the program again. Now after run this, now we have another window open here. Okay, awesome. So as you can see right now here, we have a window says autos here, and also we have another window here says call stack. So on top here at the stack frame here, eventually there are a few like breakpoint operations here using functions. As you can see on top here, you can click here at step into to step into the program to see that how each line of code has been executed now based on the memory allocation of this program. So you can also use like the keyword function 11 step in the program. As you can see right now here, we eventually jump from line 7 to line 9, which is here, and you can see the time elapsed in between 23 milliseconds. So as you can see, the value beneath here, what happening is that now the name from PTR stored now the hexadecimal like value of this type will be int. So eventually we trying to verify the condition of this PTR segment here, and it's going to be true. If you come on top and click there again, when you jump into the if segment, as you can see, the SOPTR initialized to 45 now is going to be stored eventually in this variable here, as you can see. So after this, if you click on top again here, we're going to have now an output of the value being displayed, as you can see here, type in the integer again. As you can see, the breakpoint now justifies by saying each line of code has been executed now sequentially based on sequences, and it justifies that the program now works properly. So if you click on here, you can see we jump to the delete keyword. After this also now it displays on the delete keyword. We're going to release now the PTR pointer value 45 from storage eventually. Awesome. Then we're going to pause, of course, basically here. See, awesome. So guys, you can see now that eventually our program works properly right now because based on a few operations. Now, what is also important to remember is that if you didn't have the delete keyword here, let's say for example didn't have it here, and you want to eventually now run your program, the program will work properly, of course, eventually you can see here, but the level of complexity will be difficult to remember because think about it. Let's say for example, let me include the breakpoint again here, and run the program again. Okay, now let's step into the program again line by line. As you can see, we jump from line 7 to line 9 again, to line 35 again, which means like line 11 of the code also again. We jump to line 13 again. As you can see, it jumped to line 27. Right now here, the program is still like ambiguous because now the delete keyword hasn't been specified in the program right now here. But the memory consumption can have leakage, as you'll see. Awesome. Okay, so guys, another side note also. Always checking if your memory allocation using the new was successful before using the allocated memory, because why? It's very important to always match the new with the delete keyword. Very important. Now let's change this and write the new keyword and delete it and let's say with an array. And let's hit int again. Let me say num. Arrays. Awesome. New int. Let's say 5 elements. Okay. Let me say again, because now in installed and say numbers. Okay, after numbers, is not installed. I mean there. Let's just say okay. After numbers now, gonna be, let's say 100, 50. 60, 25, 85. Okay, awesome. Give me error here. Too many initialized variables. Okay. Okay, so basically right now here, okay, too many initialized values, which means okay, initialization now is off. Let's say example here, let's come back here. Now the number of errors, now because now with the reference is here. Let's just do this and start. Say for example, going to be the first index. Now because we'll install a few of them here, let me just remove these. number gain of arrays, which means the second index will contain, so click here again. Numbers again, second, so the third index will contain eventually now the value for let's say 85. Let's change the numbers randomly. Fourth index will contain eventually third one, then eventually let's say 65, and the last one will contain eventually number of arrays. Let's say for example so 300. Awesome. Okay, so basically right now here we're just storing these values here. You can also use a for loop here nicely to eventually iterate over this storing these variables. But now based on this, let's say for example also here now, let's just see out the statement, for example, of one of these lines of code. If we say cout the index, let's take 3 indexes. For example, it is 0. So now here number of arrays, index 0. Point here. Point here. Awesome. Let me just take this again. Copy this. Take 2. Take 4. 2, 4. Awesome. So after this, also very important, we have to also delete the memory also from here, which means the delete keyword needs to also be used. So it'll be the number arrays. Awesome. So let's run this and see what's happening. Awesome. As you can see now, we again just use eventually arrays with the new and the keyword. As you can see here, we have a few variables displayed here, 100, 85, and also 300, based on our initialization in the main function. Awesome. So as you can see, guys, the issue with the new and the keyword is the memory leakage that can affect your program's performance and stuff. But in terms of the use cases now, it is standard to use them properly. But there must be always a point where now to make sure that now you have a new and the keyword being used together eventually. And also, in our current video, the upcoming 2 videos, we're going to be focusing more on these. But now, we'll be video about smart pointers, because truly speaking, avoid using raw pointers in the memory allocation when possible. Because why? We mostly use smart pointers, because smart pointers they use the new implementation of pointers, like the unique pointer, share pointer, for better memory management and also exception safety. But we'll see those in the video for smart pointers down the road. So guys, I hope you enjoyed the video. If you have any questions, comment down below, and also don't forget to subscribe to the channel if you're new. Thank you very much.